All right, so 2a is the integral of sine to the fifth of t cosine to the fourth dt. Now, of my strategies that I just went over, which one applies? We have an odd power of sine, so we strip off one of them and turn the rest into cosines. Okay, so integral, I'm going to pull off one of the sine t dt off to the end, and then I'm going to have sine to the fourth of t cosine to the fourth of t. Now, how do we turn the rest? Say that again?
1 minus cosine squared t squared.
Okay. So, yes, we're changing this into cosines. Sorry, I'm right today. Never cosines. So remember, sine squared of t is 1 minus cosine squared of t. So if I have sine to the fourth, that's 1 minus cosine squared of t squared, right? Since that's sine squared of t squared. And then cosine to the fourth of t times sine of t dt. Make sense? And then what do we do? Well, no, there's no reason to change these other ones to sine.
Oh, because now you have it all.
All of this is now in cosines, and if I let u be cosine, I can get all this in terms of u, and then du is this, right? So now we let u equal cosine of t. Du, well,
So you literally could have chosen either of them to do that with.
well, the reason it worked out nice with sine is because of the odd power.
Negative sign.
If I had pulled that off of the cosine, I would end up with an odd power left behind of cosine, which I can't turn into sines easily. But I can turn even powers of either sines or cosines into the other.
So let's say the equation that you started off with was a sine for cosine.
Okay, that's where we go back to this last suggestion on this page. Ooh, I don't know what I just did there. If powers of both sine and cosine are even, then we use these formulas here to replace them. And what that does is that takes the square out of it. Right? Notice there's no square over here, and those are easier to integrate.
And then you just square that equation because you have two of them.
Yep. And so you'd actually have to do it twice, because you end up with another square in there once you've squared something that doesn't have a square. But then you can apply that formula again a second time. And we did an example like that on that notes, I think. Right here, the sine to the fourth was an example like that, where we had a sine squared, we replaced it with that formula, and then when we squared everything, we got a cosine squared, so we had to replace it with that formula again. Okay, so if you go back and look at the notes on that 7.2, that's exactly what we were doing. All right, so back to here. Du is, you said sine of t, dt, but you meant negative. Because the derivative of cosine is negative sine.
Yeah, I corrected it.
Which means, by the way, I need
Negative inside of
a negative in here, which means I need a negative outside. Okay. So now let's go substitute everything in. I got a minus out front. What do I have as my integrand now?
1 minus u squared times u squared squared. Beautiful. E.
And I would multiply this all out. So off here to the side, boop, 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 boop. We're doing 1 minus u squared times 1 minus u squared gives me, by FOIL, 1 plus 2, nope, minus 2u squared plus u to the fourth. So then if I multiply that times u to the fourth, I get u to the fourth minus 2u to the sixth plus u to the eighth. Okay, so I FOILed this and got that right there. And then I took this u to the fourth times everything, distributed, and that's how I got that. I mean, you can write it all out here, but I like scratch word just as well. I mean, it's taken the time to multiply this out. Because when it's multiplied out, it's just a polynomial. Polynomials are a piece of cake. Or as we say in math class, easy as pie. You know, if you'd had Cal 1 with me, all of these jokes would be old and tired by now. But since
No, they already are.
I'm a little disappointed that Dr. Fawcett didn't pass some of those along to you, since she had me for Cal 3, Cal 4, several classes here.
Cal 4's on fun.
Well, all we did was took Cal 1 through Cal 4 and squeezed it into 3 semesters, so it's the same amount of material. We were just taking too long to go through it.
So they just don't think, is Cal 4 still a thing? Or
No, we do 3 semesters. But we've added an hour to Cal 1 and Cal 2 now.
Mm-hmm.
So what used to be 12 hours, sorry, 3 times 4, 12 hours is now 11 hours, because it's 8 plus 8 plus 3. So it's about the same amount of time altogether. Math is hard. No, Cal 1 through Cal 3, but we cover through what we used to cover in Cal 4. So what's now Cal 2 used to be like the end of Cal 2 and the first half of Cal 3. And what used to be Cal 4, which is what is now just the last 2/3 of Cal 3. Can y'all integrate this?
Yeah.
Different schools do different things. You can go to a school and they'll have 4 semesters. Most schools now have 3 semesters of calculus.
Good. U to the 5th over 5, 2u to the 7th over 7, and u to the...
And then, oh, well, I got to be careful. My minus sign is actually out in front of everything, right? So technically that's minus u to the 5th over 5 plus 2u to the 7th over 7 minus u to the 9th over 9 plus c. But now you got to plug back in your u. Negative. And what was u?
U cosine 5
Cosine x over 5 minus 2 cosine to the 7th of x.
Why did you stop using t?
I don't have any idea.
Oh, okay.
I
was
forgot
just
that it
making
was
sure there
t.
wasn't, like, some kind
No, I wasn't paying attention. They're interchangeable, as long as you're consistent. Actually, I would probably count them off for that, so they're not interchangeable.
You got x in the whole, it's supposed to be t, you do it wrong. And I've done that too many times.